Hello, I'm Reggie York. This is a presentation on sampling in evaluative research for the human services. I'm at the University of North Carolina, Wilmington. This presentation is about how the sample and population are related but different in evaluation research. It's also about the description of the random sample and other types of samples, the basis for scientific generalization and speculative generalization is discussed. I distinguish between those two ways of generalizing your finding from your study to a larger population. To whom would it be, in your mind, relevant on either a scientific basis or a speculative basis? Okay. Samples and populations. The sample is composed of those persons from whom data have been collected for the measurement of the target behavior that is being treated. We're talking about sampling in evaluation research for the human services, by the way. So we're talking about, for the most part, evaluating how well services have worked with the clients. Sample those persons you've collected data from. The population is a larger group of persons from which the sample was selected. If you selected clients from your caseload, perhaps as the sample, and you collected data from all those persons, perhaps the population would be all those persons served by your agency, or those served by your agency with a similar diagnosis or something of that nature. But the population is bigger than the sample. You do not define the two as the same thing. Random samples. Let's think about this a minute. A random sample is a sample that was specifically drawn on a random basis by the researcher. If you take a list of all clients served by your agency for the past year, or let's say current clients, you pull on a random basis names from that list, then that would be a random sample of the persons served by your agency. Now, I ask you this question: are your current clients a random sample of clients served by you in the past year? No. They're your current clients. That would be a convenience sample, not a random sample. So the persons from your sample had to have an equal chance of being in your population had to have an equal chance of being in your sample. How about this one? Are the students in your class a random sample of students in your program? The answer again is no. You're not there on a random basis. No one picked you at random to be in your class. So you're not a random sample. Unless they did, of course. And sometimes that happens, but that's not the normal thing. A way to select a random sample: a study population is chosen. The sampling frame is chosen. This is the list of persons from whom a sample will be drawn. So you first have that list of all the people, for example, then you draw from it. Persons are selected on a random basis. The persons selected would be the sampling units, but you select them on a purely random basis. There are several options for selecting a sample. By the way, a random sample means that everyone in the population had an equal chance of being in your sample. That happens if you just pull them at random. It's like pulling names out of a hat or something. We're finding a random list of numbers or something that you use for that particular purpose. So options for doing this randomly: ask the computer for a set of random numbers. You can do that. You can use a table of random numbers from a research textbook to select the number of the person. You can number everybody and then select numbers at random and go back and then select those particular persons. The systematic random sampling method is one way that I often use. It's a fairly simple thing to do. This is how you do it. You determine the sampling interval as follows. The interval is every nth one. Divide the size of the sampling frame by the size of the sample to be selected. Example here is you have 356 students in your program. You want to select 50 at random. So your sampling frame is 7.12. Of course, you want to pick in essence, it means you pick every seventh person. So you basically use a sampling interval, select persons from the sampling frame. In the above example, you would select every seventh person on the list. After first selecting someone at random from the first 7 people. The first sampling interval, the first sampling interval will be 7. Pick something at random, use some random method, flip a coin or whatever it is that would work for you to make it random. If that person's number 5 and you're picking every 7th person, then person number 2 would be on your list to be selected from your sample would be person number 12. Number 5 first, plus 7 is 12. Plus 7 again would be 19, so the person number 19 would be the next one. Here are a couple of samples that cannot be scientifically generalized. By scientific generalization, I mean you have the ability, because of sampling method, if you can scientifically generalize, it means you have a scientific basis for estimating sampling error. You can do that with a random sample. The most likely kind of sample you will have is a convenient sample. You simply select those persons convenient for your study, like the clients in your caseload, or all the clients served by your program at the present time. Snowball sampling is asking key informants to identify persons of a certain type that might be included in your study. Then find that group and ask them to identify other people of the same type. Then do the same for the next group. An example I would think of there would be if you're looking for a sample of homeless people, perhaps you could go to one homeless shelter, ask people to participate in your study. Also ask them to identify other homeless people they know. And you get those people's names. If you can find them, then you ask that second group to serve in your study, but also to identify additional people. That's known, of course, as snowball sampling. Let's talk about scientific and speculative generalization in a few more minutes. The results of studies using samples that were not drawn on a random basis cannot be scientifically generalized, but you may be able to generalize on a speculative basis. Speculative generalization. Well, let me first of all say something about what we mean by scientific generalization. If you have a random sample, you have the basis for estimating random error. I'm not going to go into random error and how to do that, but I'm just simply saying with a random sample, you can scientifically generalize because of that. On what basis can speculative generalization be undertaken? That's a good question. That has to do with what you know about the clients, the people in the population to whom you'd like to generalize, and compare it to those you did have in your sample. Here's an example. What do you know about similarities and differences between your study sample and a bigger population that's relevant to your study? Do you know, for example, that persons in that population you're trying to generalize to are similar in age, in gender, in race, in severity of problem, and other kinds of things that might make your sample different or similar to that other group? When we're trying to generalize, of course, we're trying to say, to whom would this study be relevant? We have data from our sample. And let's say that there was a 40% gain in between pre-test and post-test for your sample. Well, that's a reality. You measure that, that's what you have. Now the question becomes, is this result relevant to all the clients we serve, or all the clients I have served in the past 5 years, or whatever? You need to think in terms of what is similar or different between this sample from whom you drew data and that other population. A good question would be, are the differences or similarities relevant to your study? For example, is age relevant to a client's response to your intervention? Do you think there's any reason to believe people would respond differently at a different age? Well, of course, you could even examine that yourself if you have a large enough sample. and examined whether or not persons of a different age in your sample responded differently to the treatment in terms of outcomes. They had better outcomes or not. Is income level or culture or race relevant? So you only need to worry about the kinds of things that are different between your sample and a given population that really would be relevant to the study you are undertaking. You could use data for speculative generalization. Clients of an inpatient treatment center for substance abuse were followed up 2 years after discharge. This is a study I was involved in many years ago. But what happened was more than half could not be located 2 years later when they were doing the 2-year follow-up study. In fact, it was less than half, as I recall. So what to do? Can the results of the follow-up study be generalized to all those discharged during this period of time? In other words, are the results from this relevant to how effective this particular agency program is to this particular population? So basically what we did is to examine what was known about those who were found and those not, but looking at records to see if was there differences in age, in how long they had had a substance abuse problem, or other kinds of things that might be relevant to the findings. Again, one of the things you could do would be to just simply take your data and see if certain variables about your clients in your data, that is to say your sample, are correlated with the outcome. And the more you find that out, then the more you have a basis for looking at whether your sample is similar or different on relevant variables to a given population to whom you would like to generalize your findings. Okay, let's review. This has been a very basic introduction to sampling. There's a lot more to be learned about kinds of sampling and sampling methods and things of that nature. First of all, can the results of your study of students in your class be scientifically generalized to all students in your program? Well, the answer is no. You don't have a random sample. True or false? The results of your study cannot be generalized to a sample because generalization means going beyond your sample to a larger group of people. So you would not say, I'm generalizing only to the sample, because technically you're not generalizing until you're going beyond your sample. True or false? If you use a systematic random sampling method and wanted to select 50 persons from a list of 200, the first person selected would have to come from the first 4 persons on the list. That's correct, because you're picking 50 out of 200, which is 1/4, basically. Next, the most common type of sample used in everyday evaluation research is a random sample, convenience sample, or a snowball sample. Well, the answer is a convenience sample. It's not very often that in evaluative research for everyday living and everyday practice that we have an opportunity to draw a sample on a random basis. Okay, that summarizes what I've said in this particular brief introduction to sampling for evaluative research, and I hope this will be of help to you.